So let us begin with a relatively simple problem. Just for some simplicity. Maybe this is 40 degrees. Okay, very good. Now this length here is L1, this is L2, that is L3, this is L4, this is L5, and it drives this slider. This angle is theta 2, this angle is theta 3, this angle is theta 4, and the way I have drawn it, this is slightly downward, so I will draw it like this, but I will write minus theta 5 because theta 5 is also measured counterclockwise. Okay, and I need to locate the slider. I am going to use blue here for slightly greater clarity. So from this reference point over here, I will call this distance one of the coordinates. That will be 6, and this distance has to do with the location of the line on which it slides. So this b is a parameter. Okay, so our parameters are L1, L2, L3, L4, L5, B, and phi, given theta 2. First job, find theta 3, theta 4, theta 5, and s. See, there are 4 things we need to get. 2 complex equations will do it. Okay, let us write our loop equations. I'll have to go back to that window, but we will write 2 loop equations. They are complex, and we will be able to find the 4 unknowns. What are our loop equations? So the first loop equation is this one. I have to reach this point. I can reach it in 2 ways. One like this and like this, and the other like this and like that. Okay, so we come here, and our first loop equation is L1 plus L4 e to the power I theta 4 is equal to L2 e to the power I theta 2 plus L3 e to the power I theta 3. Of course, we will take this and move it to that side and set it equal to 0. That is a different matter, but this is one loop equation. We want another loop equation, and that loop equation has to do with locating the slider, and we can do it like this. We can come like this and go like that. Otherwise, alternatively, we can go like this and go like that, and we reach the same place. Okay, so our second locating equation, we can start with 04. It doesn't matter, we can start from 04, and so we will write B plus this distance is S, e to the power I phi. Now I want you to remember that phi is constant. Phi is 40 degrees for this problem. It is S that is unknown. This is unknown, or a variable. Phi is constant. Okay. Now we will complete the loop equation by saying this is equal to, the one with L4 and L5. So this is S again there. Yes, S here. S here. Right. L4 and L5 is equal to L4 e to the power I theta 4 plus L5 e to the power I theta 5. Let us count our unknowns. For that I will use red here. Theta 2 is known. This one is unknown. I will write U here for unknown. Theta 3 is unknown. I will write U here for unknown. Theta 4 is already listed, so it is not a new unknown. Theta 5 is a new unknown, and S is a new unknown. Remember that phi is a constant. So, two complex equations, four real equations, by which I mean two real parts and two complex parts. Sorry, two real parts and two imaginary parts. Okay, so four real equations. Given theta 2, we can find it. Let us try some tentative variable values. So let us say that L1 is equal to 8. Let us say that B is equal to 4. Let us say that L2 is equal to 5. Let us say that L3 is equal to 3.5. Let us say L4 is equal to 6. And let us say L5 is equal to 12. And let us say theta 2 equals 60 degrees. This is now the given data for this problem. So the first thing I want you to do, and in the next discussion sessions you will solve them, right? I want to see solutions. Next discussion group, you must have your own MATLAB solutions. Okay, problem 1, given inputs, left, right over there, I've given them here, given these inputs, find the relevant variables. Very good. Second system. Second system is a little tougher, but the principles are the same and we will see how it works. Okay, so for the second system, I want you to first see that if I have a triangle, that is one body. Yes, so if I have a triangle like this, in that case, for example, if this angle is given, let us say this angle is phi. Okay, now over here, let us say this angle is alpha, this angle is beta. Okay, let us say this length is LA, let us say this length is LB, and let us say this length is LC. Okay, then how do we write equations to solve for the various things that we want? For example, how do we find alpha and beta? You know how to find alpha and beta. But if you don't, and if you are enjoying the MATLAB solution process over here, then you will know how it goes, because I'll go from here to here. Let me use red now. I'll go from here to here in two ways. So I will say LB e to the power I phi is equal to LA e to the power I phi plus beta, and then I have this angle, right? So how do I do that? So from here, this vector is the same as this vector stretched and rotated counterclockwise, right? So this vector here is plus, and then I will have to say minus LA e to the power I phi plus beta. So this is this vector, just the opposite, right? It is not this one, but it is this one. It is not this one. Okay. Now this one has to be multiplied by LC over LA. So now it is stretched and it is the same length as this LC. Now I want to rotate it by e to the power, by a further angle alpha, so that is e to the power I alpha. Okay, so this is my equation. I am writing it in a roundabout way to make the construction clear to you. You realize that this LA will cancel. Okay, and you realize this negative is there, but the length is LC. So really what we are talking about is this vector here, right? Negative, because this one is given as negative of something, so then that what we are talking about is this vector. All right, and what is this vector? This vector can be taken as this vector plus this vector. Okay, so I think if you look at it, it should work out. Okay, however you do it, you can do it directly as you like, or you can find the properties of the triangle like this. I don't mind what you do, it should be part of your program. Okay, now there seem to be a couple of extra marks here which I will remove. Go back to the pen. Let us try this problem. This is one body here, this triangle. How many degrees of freedom and things like that? Let us check. So this is 1, 1, 1, 2, 3, that's body 4, this is body 5, and that's body 6. Okay, so there are 6 bodies, n equals 6, 3 times n minus 1 minus 2 times the number of joints. 1, 2, 3, 4, 5, 6, 7. So it's a single degree of freedom system. Professor Dasgupta has addressed this system, considered this system with you, and you know about this system. So now we are going to look at this one again using these MATLAB calculations, nothing new for you. Okay, so let this length be L1, this is L2, this is L3. Over here we have, let us say this is LA, well, what did I have here? LA, LB, LC, doesn't matter, but still we will do this. We will say LB, LC. Some parameters will be given, and this over here is L6. Okay, all right. This angle is given, let us say this is theta 2. This angle is to be found, that is theta 3. And then over here also we had this angle phi here, which is now part of our unknowns. So this is theta b. This angle alpha and this angle beta are properties of the triangle that you have found. This angle is theta 5, and this angle here, because I'm measuring in the other direction, we will write as minus theta 6 because of the arrow, right? It is minus theta 6. So if this is 10 degrees, theta 6 is understood to be minus 10 degrees. Alright, now let us write our loop equations. Remember again, theta 2 is assumed known, others are not known. How many unknowns are there? Theta 3, theta b, theta 5, theta 6. You see there are 4 unknowns. Alpha and beta are known. Okay, given these 4 unknowns, 2 loop equations should be enough, and one will go from here to here to here and will be set equal to this plus that. Okay, alternatively we can go, let me use red here, maybe easier to go from here to here, then here to here, and then there, and then come here from there and come like this. That should be all right too. So let us write that loop equation, the red one. Okay, so we will write L1 plus L5 e to the power I theta 5 plus LA e to the power I theta b plus beta, which you have found. This is unknown, this is known. Okay, so I've reached this point here is equal to L2 e to the power I theta 2 plus L3 e to the power I theta 3. Okay, so that's one loop equation. We need another loop equation, and that loop equation has to do with knowing where this hinge point is, right? So we have to know that this is out a distance a and up a distance b. We have to know this. We have to know the location of that hinge. Okay, so the next loop equation is like this. It is measuring from here, a plus b I is equal to, okay, and then we have L5 e to the power I theta 5 plus LB e to the power I theta b plus L6 e to the power I theta 6. So you see we have 2 loop equations. They have a real part and an imaginary part. We have 4 scalar equations using MATLAB. Given reasonable initial conditions and parameter values, you should be able to find the answer. Let's guess some reasonable parameter values, and these I will do in a slightly darker blue so that they stand out. Let us say L1 is 10. Okay, so that's 10 now. In that case, L2 is 5, L3 is 6, L4 5 is about 4. L6 is 5. That leaves LA, LB and LC, and LA is about 2.5 and LB equals LC is equal to 3 and theta 2 equals 65 degrees. So you should solve this or write to me in case you can't find an answer. Okay, and that is your second problem. This you should be ready with during your next discussion session. Okay, so now we have the position equations. And with this we have found the position. Now let us say theta 2 dot is equal to 1, theta 2 double dot is equal to 0 for both problems. So first let's do a velocity analysis. Let's move to the equations we have for the first system. They should be here somewhere. Yes, here they are, right? So I will use this dark blue color to write here, you see. So I'll have I L4 e to the power I theta 4 dot. This one dot is 0, nothing, is equal to I, sorry, I don't mean that, I L2 e to the I theta 2 dot plus I L3 e to the I theta 3 dot. Okay, so here this dark blue equation gives you the rate equation. It has a real part, imaginary part, and you can find things with it. Of course you still need this one as well. So over here this equation, derivative b dot is 0, so I have s dot e to the power I phi, remember phi is a constant, is equal to I L4 e to the I theta 4 dot plus I L5 e to the I theta 5 dot. With this equation here, this equation, and here this equation, with these two you have theta 2 dot is known, so you have 4 unknowns. You should be able to find the rates. Okay, let's go to the other problem here. These are my equations, right? So over here also we will take derivatives. Find rate equations. And find rates. Let me emphasize, in the next discussion session you need to know how to do this. So, given theta 2 dot equal to 1, theta 2 double dot is equal to 0, find all angular velocities and s dot, both problems. Okay, so that is the next part. I mean, this 2 is a follow-up to this 1, so I should write here in red 2. Okay, then you differentiate again and you do the acceleration analysis. So for example, suppose I was doing acceleration analysis, then let me differentiate this one. Okay, I'll get s double dot e to the I phi is known, is equal to minus L4 e to the I theta 4 dot square plus I L4 e to the I theta 4 double dot, and then another two terms here from differentiating that one. And over there, let me take blue now to point out your unknowns now are this double dot, and similarly one double dot from that derivative, and the others are to be collected and put on the right hand side of your system of equations. In this way you can find the accelerations as well. Once we know how to find such accelerations, after that we are in a position to do force analysis. Okay, so this is the third part. Find angular accelerations and s double dot for both problems. Okay, have them ready in your MATLAB. Okay, be ready to explain what you have done. All right, and then we will see. So this is how we are going. Next we will do forces and moments. Okay, I hope you found this relatively easy. It is a natural follow-up to the previous two lectures. I will stop here for today.